What we have done up till now is find out this basically how many trips attracted and produced. Okay, but we don't know if they are attracted. For example, 100 trips are produced from zone 1, then where they are going we don't know. And if 240 are attracted towards zone 1, then from where they are coming we don't know. Okay, so either we know basically one end of the trip, but we don't know the other end of the trip. Okay, and this is what we are trying to find out in trip distribution stage. Okay, this is the process by which trips generated from each zone are allocated to other zones in the study area. Okay, so whichever trip is generated, where it is going or where it came from. Okay, this is what we are trying to find out in trip distribution. Okay, now these trips, the trips which you will consider for trip distribution, they can be internal, meaning their zone, their starting point and the ending point are zones which are within your study area. So they are internal. Okay, they started within the study area, they ended within the study area, or they can be internal external. Internal external means either they started outside the study area and somebody came in, or either they started from the study area and then they went out. So they are internal external. Okay, so both types of trips must be considered for trip distribution. Okay, internal as well as internal external. For trip distribution, there are different methods, but we will discuss only two, okay, which are gravity model and growth factor model. So we only discuss two, okay, and within growth factor model, we will see some variations as well. So the gravity model is more considered more common, okay, is considered more popular because it's very simple and it's accurate, and the data which you require for gravity model can be taken from different government departments. So it has the added advantage that you don't need to, most of the data which you need for gravity model is available with the government departments. Okay, so this is why gravity model is more popular and more used. Okay, because it's simple, accurate, and requires less effort. According to gravity model, the trip from zone I to zone J, represented by Tij, can be calculated using this equation. Now in this equation, what are we using? Trips produced, Pi, from zone I. Total number of trips produced from zone I, the one which we have calculated in the previous steps. Aj, trips attracted towards zone J. Trips attracted towards zone J. Okay, so again, something which we have calculated in the previous step. Multiply by f and k. What is f? F is a function of travel time, and usually they have inverse relationship. Function f and travel time has inverse relationship. So when travel time decreases, f value increases and vice versa. Okay, so it's not exactly f equals 1 upon travel time. It's not exactly like this, but I'm telling you the relationship is inverse. Whenever travel time decreases, f increases and vice versa. Okay, so it can be inverse, like a simple inverse, or it can be 2 upon travel time, or 1 upon travel time square, something like this. Okay, but the relationship will always be whenever travel time increases, f value will decrease and vice versa. And then we have a factor k. K is a socio-economic adjustment factor between I and j. Socio-economic adjustment factor between I and j. For example, let me give an example that, so first of all, k is only used if you feel there is some factor which is not incorporated into this equation or the previous trips attraction and production stage. There is some factor between the two zones which is affecting the travel, but is not incorporated in this equation or the equations or the procedure which we have used for calculating trip attractions and productions. Okay, so for example, A practical example can be that the travel between Saudi Arabia and Bahrain. Okay, somebody comes to Bahrain for job. Okay, there are many people who come to Bahrain for job from Saudi Arabia and vice versa. The other way happens as well. Okay, these people who are coming to Bahrain may have another zone in Saudi Arabia which is closer to them, but they don't go there. They come to Bahrain because maybe the businesses here are more relaxed. Okay, they have more facilities maybe. Okay, maybe he has some relatives here. Okay, so something like this. Okay, especially I have observed, I think this will now reduce, but I have observed it a lot that especially girls from Saudi Arabia used to come a lot to study in Bahrain, even boys. So people used to come to Bahrain for study. Okay, and there are universities in Saudi Arabia as well, which will be closer. It will have less travel time to go there from their house as compared to a university in Bahrain, but they still come. Okay, so this is related to their own perception, something related to the socio-economic factor or the judgment of the traveler. Okay, so this thing cannot be incorporated in this equation or the previous procedures which we have seen for trip attraction and production. Okay, so in that case, you may introduce a factor k. You may decide a value of factor of k, which can help you calibrate the number of trips for this particular reason. Okay, if you feel all zones are behaving equally, there is no special attraction or production, or there is no special factor, there is no extra consideration which can affect trip production or attraction between these two zones, then k will become 1. Simple. K will become 1. Okay, k1 means it will have no effect, right? K is multiplied. So when you make k as 1, it doesn't have any effect. Okay, so that means if because of some reason the trips are increasing, then they should be from this equation. For example, you are getting 10 trips, but the actual number of trips is 15. So that means there is some extra factor which is causing the trip attraction between the two zones, and that then the k factor should be introduced, maybe 1.5, to make the 10 equal to 15. The 10 which you have calculated and the 15 which is actual. Okay. Similarly, if the trips are less, actual number of trips are less than what you are getting from the equation, that means k should be less than 1. So I multiply k with this equation, so it will give me less number of factors, or less number of trips than the equation will give normally. Okay, but in short, k is a socio-economic adjustment factor, and to determine the value of k, you must have a good idea, a good insight about the zones between which you are calculating the t value. Okay, otherwise k by default is taken as 1. Okay, so this is the numerator and the denominator. You take the same term and you add it for all the trip attraction zones. Okay, the term you have only done it for j zone. Now you do it for all the zones. So for example, in the previous case I had 3 zones, so I will add this term for all the 3 zones. Okay, in the denominator. Okay, so this is how you will get the number of trips between zone I and j. Let us look at an example. Okay, we have study area with 3 zones. Data is given. This is the data which is given. So number of trips produced and number of trips attracted for each zone is given. Total is equal. That means balancing is done. This is, I think, the travel time between each zone, and on the basis of travel time, they have already calculated the F factor. Okay, so you can see here the travel time increases, F factor decreases, but it is not exactly 1 upon T. F is not exactly 1 upon T. Okay, so they are using some equation, but we don't know that. Okay. So F is given, trips attracted and produced is given, and based upon the intrazonal travel time for zone 1 in larger because of the geographical characteristics. So if one, for example, if I come here between zone 1 and zone 1, this is what we call as intrazonal. If the trip is ending and starting in the same zone, within the same zone, we call this as intrazonal. Okay, so between 1 and 1 is just 2 and 2 intrazonal, 3 and 3 intrazonal. So you can see intrazonal travel times are also large than interzonal travel times. For example, if you go from 1 to 2, it will only take you 2 minutes. But if you are traveling within zone 2, it will take you 6 minutes. Okay, so this has to do with the transportation network and the characteristics of the zone. If the zone is very large and when you are traveling between the zone, you are traveling on the local streets, then your travel time will be higher as compared to going to another zone where you go directly by a highway, by a freeway. So you go from a street to a freeway, and then after 2 minutes you are in the other zone. Okay, but when you are traveling within the zone, you go from one street to another street, the traffic is congested, more traffic, and so on and so forth. So this can happen. The intrazonal travel time can be more than interzonal travel time. Anything else? Okay, if you go to the book, you will find a graph which is showing the F values and the T values. Okay, but again, they did not give any explanation. So this will come from trial and error as well. And K factor is 1, so there is no special socio-economic factor attracting the trips between the two zones. So they are saying determine the number of zone to zone trips through two iterations. So we need to perform 2 iterations. Okay. So this is the procedure here, and we will do it over here. Okay, 1, 2, 3. 1, 2, 3. Okay. So the equation is you must know the number of trips produced. Okay. So number of trips produced for zone 1, 140. Multiply by number of trips attracted towards zone 1. This is 300. Okay. And oh, sorry, I have to multiply by K and J as well. Oh, sorry, K and F as well. So K is 1. Okay, forget about it. K is 1. Okay, so multiply, don't multiply, no effect. Multiply by F as well. So between zone 1 and 1, the travel time is 5. The travel time is 5. Okay, so for travel time of 5, the F value is 39. Okay, so multiply by 39. Okay, then add this attraction factor for all the 3 zones. Okay, this term for all the 3 zones. So 300. So for zone 1, I already know. For zone 2, 270. IJ, right? Okay. So 270, and from 1 to 2, the travel time is 2. So for 2, the F factor is 52. 270, 52. And then I have 180, and then from 1 to 3, the travel time is 3, and this is 50 then. The F factor is 50. So 180 into 50. Okay, so you will give me this value. Okay, and I will do the same thing for trips from zone 2 as well. From zone 2, the produce is 330. Okay, I'm still talking about zone 1, so this entire factor will remain as it is. Okay, and then for zone 3, the trips produced is 280. So 280, and again the entire factor will remain as it is. Let me take it from here. From 1 to 2. The trips produced is still 140. Trip attracted 270. The F factor from 1 to 2, 2 minutes of travel time, 52. Okay. So 300 is for zone 1. That's fine. 1 to 139. 180 is for zone 3. That's fine. And 1 to 3, the travel time. Okay, that's fine. So this will be 330 into this entire factor. Okay, so only the numerator has changed. Then 280 into the entire factor. Okay, then for zone 3, the number of trips produced. This is 1 to 2. That's fine. Number 1 to 3. So again 140 multiplied by the trips attracted to zone 3, which is 180 by 50. Okay. This will be 2. Let me just check. 339. 9. Okay. Okay. Give me the values. I think 2 to 1. 2 to 1. 2 to 1 is 2 minutes, and 1 to 2 is also 2 minutes. 2 to 2 is 6 minutes, fine. 2 to 3 is 6 minutes, and 3 to 2. 3 to 2 is also 6 minutes, yeah. That should not change. 1 to 1, 1, 3, 1 to 3 is 3, and okay. Okay. Give me the values.
$47. 175. 94. $57. 133. 113. 36. 85.
Sorry.
85. 73.
This is the first iteration basically. What we have done is the first iteration. Okay. Now what we have to do is we need to calculate because if you now add the number of trips. Okay. So for example, trips produced for each from each zone. So if you add these numbers, okay, if you do the total of them, let me add column on the right and let me add one row at the bottom. Okay, now if you take the total, this should be the equal to total number of attractions. Okay, for each zone, because this is the destination then. Okay, so it is going from 1 to 1, then 1 to 2, and then 1 to 3. Okay, so the total number of total number of trips going to zone 1 should equal to the number of attractions which they gave me, which is 300, 270, and 180. Okay, and if you do the total for each row, then it should give you the total number of productions, which is 140, 330, and 280. Okay, now if you do the total for each row, okay, how much you are getting? 47 plus 57 plus 36.
140.
Okay, so in the rows you are getting the number which you should get. Okay, the number of productions is no problem. Okay, this one is 330 and this one is 280. Okay, now the problem is the number of attractions. Okay, so give me the total number of attractions right now, the total for each column.
Second row is wrong. 235.
How much?
235.
175, 133
plus 133
plus 85.
393.
393. How? Why? And what about this?
175. This one 94
plus
plus
73.
Plus 280.
Yeah, so this one should be correct as well.
Maybe there is mistake.
175 plus 133 plus 85.
Yeah, 393.
393.
Maybe I did miss. Yes.
So the denominator is not changing. Okay. If you go back to the previous formula which you have put, just
let me check.
Just keep the denominator as it is and just calculate this, or just insert these values.
First one, 111.
111. So now if you do the total, 111, 133 plus 85, 329. So it's almost correct.
Yes.
Okay. Okay. So now do the total for each column. And this is what I'm saying will not be correct. Okay, this is what we know for sure. This will not be correct. Okay, productions must be correct. If they are not correct, that means you made a mistake. And attractions will most probably not be correct. Okay.
252.
252, and they should have been 300. Okay. Okay. Next one.
303.
Next one.
194.
Okay. So now for the next iteration, what we need to do is we need to calculate the number of trips, or we need to calculate the adjustment factor for each zone, the adjustment factor for each zone. Okay, so for calculating the adjustment factor, you will take the number of trips attracted right now. Okay, and you will divide it with the number of trips given initially. Okay, so we have, for example, 300 trips for zone 1. Okay, number of trips attracted to zone 1 is 300, which was initially given. Okay, so this 300 will be multiplied by this ratio. So this is the factor actually. The ratio is the factor. What is the the ratio? 300, which was the number of trips initially given, divided by 379, which is the number of trips you have got right now. Okay, this is according to the book. It should be 379. Anyways, so let me insert a table here. On attractions 1, 2, 3. Okay, the initial value was 300 for zone 1. Then you multiply with this factor. You will get the new attraction. For zone 2, the initial was 270. 270 divided by 303. Then we have for zone 3, it was 180, 194. How much will you get?
$357.
from 2 to 1, the travel time is 2 minutes. Then this factor should be how much? 52. And it is this much. Then 2 to 2, travel time is also 2 minutes. Oh, 6 minutes. So for 6 minutes, the factor is 26. Oof. 2 to 3, the travel time is 6 minutes. Ooh. No, sorry. 6. This is 1 to 2, and the travel time for 1 to 2 is 2 minutes. That is 2. This is fine. Then from 1 to 3, the travel time is 3 minutes, and the factor is 50. Also fine. Okay, now if I come here, 1 to 3, the travel time is 3 minutes, and the factor is 50. One, two, 3 minutes, and it is 50. This is 300. Then 3 to 2, 6 minutes. The factor is 26. Three to 1, 3 minutes. The factor is 50. Okay, that's fine. Then we have 3 to 2. It is 6 minutes, and the factor is 26, which is fine. Okay, and 3 to 3, it is 5 minutes. 5 minutes, the factor is 39. I think we need to recalculate the values. Let me see if I can. Can you give me the corrected values? First, give me for column 1. If there's a mistake, I can check it. Okay, 1. Okay, so I think these values are correct. Five. Eight. Six. $280 produced from zone 1, zone 3, 300 for zone 1, multiply by the 1, 2, 3, 3 minutes, it's 50, it's fine, it's 350, then 270, 3 to 2 is 6, 636, okay, 180 is for this zone, and 323 is 5, so 5 is 39, that's fine. Okay, this will continue here, and this will continue. To okay, this is how much? 380. Okay, I'm close to the correct numbers. 380, and then this one is 209. This one 179. Okay, coming back here, only these numbers will change. 380, 9, 179. Okay, so the procedure remains the same. I made a mistake with these values basically, the travel time functions. Okay, so you can cross check it. So 2 to 1, the travel time is, for example, where is it? 2 to 1, the travel time is 2 minutes, so the factor should be 52. Okay, and then this one should be from 2 to 2. So 2 to 2, the travel time is 6, and the factor should be 26. Okay, similarly 2 to 3, the factor is 6, so the travel time is 6, so the factor should be 26. Okay, and so on and so forth. Okay, so now these are the new attractions. Then the new attractions will be 300 into 300 divided by 380. How much is that now? 237. Okay, 270. Into 270 divided.
349.
349. Okay, the last one.
181.
Okay, I will not do the complete iteration, but I will tell you what will change. The next iteration, basically the attractions will not be these numbers. The numbers which you initially had, the attractions will be these now. Okay, so for example, I will take this complete table. Okay, obviously the numbers will change. The total for trip production should still remain the same. They should still remain the same. These numbers will change. Okay, now let me add another row here. Let me call this previous total. So the previous total, on the basis of which we have we will be doing the calculation for this table, is this one 237, 349, and 181. Okay, and the total for this one will be whatever you get. Okay, so 300 will be replaced by 237. Okay, 270 will be replaced by 349. Okay, and this one will be replaced by 181. So I need to change in the denominator as well to 7. This one is 349. Okay, travel time and everything will remain the same. Okay, so if this is correct, then I can just simply take it and I can paste it here. Okay, similarly, if this is correct, then I can simply take it from here and I paste it here. Okay, and then if this is correct, then I take it from here. Okay, and do the same thing here. Okay, you will get some new numbers here, you will get some new attractions here. Okay, now in this question they said only perform 2 iterations. So this is the first iteration, you got these numbers, and this will be the second iteration. Okay, for this question 2 iterations are enough. Okay, so you will stop there whatever number you get. Okay, so here for example, if you get 200 and 300 and 180 something, you will stop whatever number you get, you will stop. Practically these numbers should be converging to each other. The new iteration which you calculate and the previous iterations you new attractions which you calculate and the previous attractions you have should be converging to each other. They should be coming closer to each other. So earlier they had a difference of less than 10%. Now their difference should be 8%. And if you do the next iteration, their difference will become 2% and 1% and so on and so forth. Okay, so the iteration should continue until the previous attraction and the new attraction are exactly the same. They should continue. Okay, so you can recalculate the values and you can see how close they are coming. But with each iteration, they should be coming closer. Okay, with each iteration, they should be coming closer. Now, practically, like I said in this question, you stop after the second iteration. Okay, but practically, when will you stop? You should stop when the difference between the previous attractions and the new attraction is 5% or less. 5% or less. Okay, so when the difference between this and this for all factors, so difference between this one and the previous one is less than 5%. This one, difference between this one and the previous one, again less than 5%. Difference between this one and this one, less than 5%. Plus or minus doesn't matter. Plus or minus doesn't matter. So either it is plus 5% difference or minus 5% difference. Both are allowed. Both are allowed. Okay. So practically, ideally, you should stop doing the iterations when you reach the stage where the difference between the previous attraction and the new attraction is 5% or less. Plus or minus doesn't matter. Okay. The procedure which we have adopted here is what we call as doubly constrained gravity model. So earlier we were calculating attractions using productions, and then we adjusted the attractions to calculate the new iterations. Okay, this is doubly constrained gravity model. In doubly constrained gravity model, we use trip productions as well as trip attractions both. Okay, initially we try to balance, or we try to find out the trip productions, which we already done, like I said earlier, that these numbers will always remain the initial value. Whatever the initial value was, this will remain the same. But then in the new iterations, you are also trying to merge or converge the trip attraction. This is doubly constrained gravity model. Initially, productions are balanced or productions are met, then you try to meet the attractions. Okay. Now, this is another example where they are asking us to, apply doubly constrained and singly constrained trip production and attraction. Okay, so we have a 3-zone system, 900 shopping based trips. Total number for entire 3-zone 900. Okay, zone 1 and zone 2 generate 400. Zone 3 generates 100. Okay, so if I make a table here, zone, attraction, production, action, 1, 2, 3. Okay, zone 1 and 2 produce 400 each. Okay, and zone 3 produces 100. Okay, so zone 1 has a shopping mall which has a parking availability and a transit service. So parking is also available, transit service is also available. So from any zone to go to zone 1, the F factor is 1. The F factor is 1. Yeah. In zone 2, the parking cost is higher. Okay, and it has lower level of transit service. So the F factor to go from any zone to zone 2 is 0.5. Okay, and in zone 3, the parking cost is very high and there's no transit service. So you have to take your car there and then you have to pay a lot. Okay, so this is like a conspiracy by the government to make you pay. Okay, so for that reason, the F factor for zone 3 from any zone is 0.2. Okay, so zone 1 is more attractive, F factor is 1. Zone 2 is slightly less attractive, F factor is 0.5, and zone 3 is least attractive, is F factor of 0.2. Let me just check one thing. Getting confused between F and K. Number 12.5. Yeah, effective. Okay, so K is still taken as 1. Okay, K is still taken as 1. They are playing with the F factor. So let us apply the each zone has 300 attractions. Okay, for each zone the attractions is 300. Okay, so again I will make a table like this and hopefully I will not make the same mistake. Okay, so they should be equal to 400, 400, and 100. Okay, so trips from zone 1 400, attraction from zone 1 300, from zone 1 to any zone the F factor is 1. Okay, divide by total. So 300, everything is multiplied by 1, right? Because we are still talking about zone 1. Okay, so zone 1 to zone 2, zone 1 to, zone 1 to zone 2 or zone So zone 1 to zone 1, the F factor is 1. Okay, no problem. From zone 1 to zone 2, the F factor is 0.5. Okay, so the attraction is 300, the factor is 0.5, and then from zone 1 to zone 3, the attraction is 300 and the factor is 0.2. Okay, the factors, right? Yeah. Okay, so this is it. Then for this one, the production will remain the same, multiply by the attraction will also remain the same, so this is slightly easier. So from 1 to 2, 1 to 2, yeah, 1 to 1, 1 to 2, and 1 to 3, yeah. And then you do the same thing here as well. Okay, then for zone 2, again 400, attraction 300, multiply by 2 to 1, again factor is factor is 1, and then 300 into 1, 2 to 1, yeah, plus 300, 2 to 2, the factor is 0.5, 2 to 3, the factor is 0.2. Okay. Production is same. Attraction is also same. So this will remain as it is. The difference will come here because the production is now 100. Okay, attraction is still 300 for all the zones. The production is only 100, and the factors are the same. 3 to 2, the factor is 0.5. 3 to 1, the factor is 1. 3 to 3, the factor is 0.2. Okay, give me the values. If you give me this value, this will repeat in most of them. So you just have to calculate two values, this one and this one. What's the first one?
Two, 3, 5, doctor.
2, 3, 5. Okay, and so this will be the same for all of them, like except the last row. Now give me the value for the last row then.
$58.
58. Then do the total for each column then. And the total will remain the same, obviously. Each column is giving how much?
5 to 8.
5 to 8. This is singly constrained. We only met the number of productions. Okay, for number of attractions, again you need to recalculate the factor. Okay, the attractions. Okay, so if I calculate the attractions here, okay, zone 1, 2, 3. For each zone, I know attractions, the previous value was 300. So 300 into 300 divided by 5 to 8. How much is this? Is this value correct? 5 to 8? Yeah, okay, fine. Yeah, how much is this?
170, doctor.
170?
Yep, 170.
Okay, so these will remain the same. Okay, so these are now new attractions, and then you apply the same with the new attractions. Okay, so wherever you are using, all these 300 will change into 170 basically. Again, you just need to calculate two values. Factors, because factors are same, you just need to calculate two values.
$179.
17. Or let me just you guys understand now, right? So I don't need to write all the values. Okay, so I just have this one. So 17, how much you said?
9.
Total? One seven nine is total?
Yeah.
Okay. This will remain 179 and 179 here as well. 179, 179, and obviously all these will change. Okay, and what about this one?
44.7. 44. 45.
So this is 179 and this is 40. How much is the total?
403.
403. $400 and 300. Reduction 300 into 1, 300 into 0.5 and 0.2. Same. Okay. Okay. Sorry. Again. 2 to 1. Is this 1, 2 to 2? Yeah. Made a mistake here. Should be multiplied by 0.5. And this should be multiplied by 0.2. Okay, so this should be half actually. So 235 into 0.5 is how much? 235 into 0.5 is 118.
117.5 or 118.
Okay, and this one, half of 58 is 29, right?
Yep.
And 20% of it, 58 is how much? 12. Okay, and this will be same. Okay, so this is 528. Then we have
Doctor, first value row 2 and column 2. Change it also.
which one?
Column 2, first value. 118 should be right.
118, yeah. And this one?
Third
This
value.
will not be 118.
47.
This one is 47. This one?
Both the same, first one and second one.
Okay. So 118 into 2 plus 29, 265, and 47 into 2 plus 12, 106. Okay, and then these vectors will change 300 into 300 to have a 5 to 8. Fine. Then we have 300 into 300 divided by 265.
339.
And what about this one?
849.
You took 106, right?
Yeah, 300 by 300 over 106, right?
Yes.
Yeah, 849.
849. Okay, and then it means that we should
Oh my
be
god.
doing the entire. Okay, so what will change here? This will become 170. Okay, for zone 2 it's 339. For zone 3 is 849. Okay. So I basically leave it up to you, okay? You calculate it. I just simply leave it here. You don't get confused. Okay. 1, 2, 3, okay, fine. Okay, so you calculated the point in this problem. What we were trying to do is actually we calculated the first iteration singly constrained. So first iteration is singly constrained. You match the productions. Second iteration, you are trying to match the attractions. Okay. Now the difference between this example and the previous example is the F values. The F values. In the previous example, F values were related to the travel time. That's it. Okay, and it was for so I did not say if the travel time for zone 1 and zone 1 is 5 minutes, so the F factor is this much. But if I have the same travel time, for example, between zone 3 and 3, I have the same travel time, but the F value will be different. No, I said in first example, wherever you have this much travel time, the F factor will be this much, irrespective of between which two zones you are talking about. So if it is 6 minutes between zone 2 and 2 or 6 minutes between zone 3 and 2, it means the same thing. F value is 26. So the F value was irrespective of the properties of the zone. But in this example, the additional thing was that F value was dependent upon the properties of the zone. Okay, so zone 1, so if I'm talking about the travel time to zone 1, then I have to consider the additional characteristics of zone 1, that parking is available and transit is also available. Okay, but when I'm talking about zone 2 may have the same travel time. For example, between 1 and 2 and 1 and 3, you may have the same travel time, but their F factor is not same. Why? Because of the transit and parking services. Okay, so in this example, they change the F values not on the basis of some particular characteristics of the zone. So even if the travel time remains the same between any two zones, because of the F factor, you will not get the same results. Because of the F factor, yeah, the F factor is different because of some characteristics of the zone, even if the travel time is same. Okay, in the previous example, any two zones which have travel time of let's say 2 minutes, their F factor is this much. Okay, but in this case, F was dependent upon the characteristic of the zone. So this brings us to this important note that what circumstances singly constrained model is should be applied, and in what circumstances doubly constrained model must be applied. It depends upon what you are taking into consideration for F and K values, F and K factors. Okay, singly constrained model is more accurate if you are taking into consideration the friction factors and the travel impedances. Resistance, we call them resistance factors. Friction factors. Okay, so the F factors and the K factors can also be termed as travel impedances and friction factors. Okay, so these are basically like shown in the previous example, some factors which you introduce because of your knowledge about that zone. You have some judgment and you have some knowledge about why people will not like to go to that zone compared to some other zone. If you have that judgment and you apply it to find out the F and the K factor, then singly constrained model is more accurate than doubly constrained. Okay, singly constrained model will be more accurate as compared to doubly constrained model if you are using some engineering judgment for the K and the F factors. If you did you calculated the F factors like we did in the first example using a single parameter which was common for all zones. Okay, it was not related to any particular characteristic of the zone, then doubly constrained model is more accurate. Okay, so the judgment is made or the choice is made when you are calculating the K and the F factors. Did you use a parameter to calculate it, so that parameter was same for all the zones, or did you use your own judgment that since that zone does not have good parking, so F should be reduced, or this zone does not have good bus service, so F should be reduced or increased? If you did that, then you apply singly constrained. If you did not do that, then you apply doubly constrained. Okay, so I hope it was clear. Now we have some other things to do as well in this topic. We have not finished it, but I don't want to start something new. Why? Because I need to explain to you what you have to do in the last submission of your term project. Okay. Now, important point, I'm recording this. Okay, good. So let me open a sheet. Okay. Now what I will do is just after the class, I will upload a folder. Okay, for the software. Even if you let me give you the name, because you are only going to use it for the term project. So even if you simply download the trial version, it is enough. Okay, the name of the software is the student or trial version is free for everybody. You can download it, and I think it has an expiry date, but you are doing it in the end of the semester. So after the semester, even if it doesn't work, it's fine. Okay, if you wish to use it after the semester, take the real version from me. Okay, so I have this software. Open it. I think Syed has already used it, right, Syed? When you were doing your senior project, if you are still using the same laptop, the software must be there. Okay. Okay, so it's a very simple software. You can see it looks like an Excel file. Okay, now what you have to do, you go to, let me open the data which you have collected. Okay, so for example, so here is here, let me open his file. Okay, now what you need to do, or what you are, the last step of the project is, you need to find out which type of travelers will be choosing the electric vehicles and which type will not choose electric vehicles. So mode choice, okay, because right now, I hope that everybody is choosing the, the car. Okay, I think more than 90% of your respondents must have said we are using car. Okay, so we have basically, for most of our travelers, we have two choices. First choice is they are using the car and they will continue to use the car in future as well. The second choice is they will shift from their car to electric vehicle, autonomous vehicle. So traditional car, present option, and the new option is to go for autonomous vehicle. Okay. Now, if I go to the data, there was a question. Email address, forget about it. Gender, language, national, income, existing mode of choice. So you see existing mode of choice, car and whatever. Okay. Current travel time. How likely are you to replace? Not this one. I think there was a question in which we asked them directly. Will you take it or not?
Before, Victor, before.
Yes.
If autonomous vehicle is introduced in Bahrain. Yeah, this one. Z. No, Y.
Why? Okay. So for example, if somebody said likely or very likely, that means he will shift. Okay, somebody answered likely or very likely, he will shift. Okay, and somebody said otherwise he will not shift. He will still be using whatever he is saying here. Okay, now for example, if I put a filter here, how many types of things I have? Most of them would have said car. Okay, so for example, if I select car here, 139 out of 193 have said car. Okay, first thing you will do is you will divide the current options, this column, into two responses. First of all, make sure that you save this sheet as a separate file, so the original data is not disturbed. Okay, don't disturb the original data, save it as another file. Okay, then from column U, divide all the responses into two categories, car and others. And now others can include shared car, bus, rented car, taxi, because the responses are very few. Okay, the responses are very few. So from the current options, you will have only two. Okay, now, so first of all, you do this with column U. Then you come to column Y and you see how many of them have said they will shift. How many of them have said likely or very likely? If they have said, if they did not say likely or very likely, that means they will remain with their actual current option. Okay, so now you will produce, or you will make another column. In that column, you will write the new mode choice. How? If somebody said likely, his mode choice is autonomous vehicle. If somebody said neither likely nor unlikely, you will write his current mode, whatever it is. So if it is car, you will write car. Okay, so in the new column, people who said likely and very likely, you will write autonomous vehicle, and people who said any other thing, you will write their current option. Okay, so two steps. I've explained here two steps. First step, divide or merge the options which are not car into one option which is others. So current option is car or any other, and then you make another column, and then the new column may have others, car, and autonomous vehicle. Okay, and the people who said likely or very likely for this question, for them you will replace the current option with autonomous vehicle. Otherwise, you will just keep the original the current option as it is. If it was car, you will put it as car. If it was others, you will put it as others. Okay. Now, after doing that, forget about all these columns. Forget about them. For the third, for this one, you have already done the analysis in the second submission. I don't want you to do it again. Whatever you have produced in the second submission, if there's a mistake, I will tell you and you can correct it and you will put it. Otherwise, you will put it as it is. Okay. But for the new analysis, these columns are not required. The columns in which you were asking them about their opinion. Okay. All these columns from Y onwards. Y is the last one, and then from Z onwards, you will not use any of these columns. Okay. So now you come here. These column, respondent ID, start date. Okay, it doesn't matter. Okay. Do you agree to proceed? Yeah. Okay. So now from K till X, you will take these columns and the new column which you have made for mode choice, you will copy them. And just copy don't copy the headings. Okay. Don't copy the heading, just copy the data. Okay, just copy the data. And so you will copy them and you will paste it here. Okay, just paste it as it is. So I will take it from here. Okay, so till X, I will take it from here, plus the new column which you have made for the mode choice, and you should not copy the column which already has the mode choice. So column U should not be copied. So you will do it like this. From J to T, you will copy all of them. Put it here. Then you will add another column here. For adding the column, you come here, variables, add. Okay. After which variable you want to add it. So you see another column. So here you will put the new column with the mode choice. Okay, the final mode choice. So let me just copy it from here for the time being, but you should be for the new mode choice. Okay, now you see some questions have yes and no. Okay, so convert yes into 1 and no into 0. Okay, or even if you keep it as it is, it can still calculate the values for you, but I will not advise it. Okay, so some columns have yes and no. Replace yes with 1 and no with 0. Okay, some columns have ranges. For example, this one. Replace the range with the mid value. So 25 and 34, just put the mid value. Okay, male and female, do the same thing which you did for yes and no. Either make male as 1 and female as 0, or vice versa. Okay, same thing with the column for Arabic as well, Arabic and English. Okay, make maybe Arabic as 1 and English as 0 and replace them, and so on. Okay, for education, okay, the least education as 1 and the highest education as 5 or 6, whatever the number is, and you replace it with numbers. Okay, so you see what I'm doing here, replacing the ranges and text values with numbers. Okay, I'm trying to replace the ranges and text value with numbers. Okay, so let's say the least education will have 1 and the highest education. So you go level by level. Okay, so if you have 5 options in the education, least one will have 1 and the highest one will have 5, and so on and so forth. Okay, so again, ranges should be replaced with 1 and so on and so forth. Okay, so wherever you have ranges, take the mid value. Wherever you have 2 options, take one option as 1, the other one as 0. And for education, you make the least education as 1 and the highest education as the highest number. Okay, and the last column just keep for mode choice, keep it as it is. Okay, then you come here, statistics, advanced linear non-linear models, generalized linear non-linear models. You come here. Okay, then you go to logit model, logit. Okay, then you press OK. Then you come here, you see variables, go here, dependent variable, the mode choice, everything else continuous predictor. everything else. Dependent variable is the mode choice variable, the last one, and everything else will go here. Okay, and then you press OK. Okay, then you go to advanced, and then you click on this backward stepwise. Okay, what it will do, it will create a model that only contains important variables. Okay, so let me, because I did not convert the, so it will create a problem for me. So let me just take variable 4, which is already in the form of numbers. Okay, these should be in the form of numbers. After converting to numbers, then you come here and select it. Okay, so you come here, you do backward stepwise. Okay, and then you click on OK.
Some of them answered with years.
Sorry?
Some of the answers are with years or years.
Okay. Yeah, okay. It's a very small data set, I can convert it. 3. If some values are missing, don't worry about it. Okay, don't worry about it. Now it should work. Dependent is this one is 4. Go here. Backward is stepwise. I think it has to do with the type of model which I'm using. Multinomial, sorry. Select multinomial. Don't select logit, multinomial. Multinomial logit. Don't select logit. Logit is only for 2 options. Multinomial logit, and then you do this. Okay. So multinomial logit should be selected. Then you come here. Backward stepwise. Okay, so what was the problem here? The problem was I only selected one variable, and this one variable was not important. Okay, and this is why I did this backward stepwise. So when you do backward stepwise, it will show you the final model which has only important variables. So out of, let's say, these 6 variables or these 11 variables, only 2 are important. So it will eventually show you a model in which only 2 variables are there. Everything else will go out. Everything else will not have any coefficient. Okay, so what I would suggest, okay, so now when I remove backward stepwise, now it has shown me the model. See now, so I remove backward stepwise from here. I selected all effects, and now it is creating the model. Okay, so once the model is created, you should select backward stepwise. Okay, but I don't want any variables which are not important. So backward stepwise, then you create the model. You should have converted all of them into numbers. So some variables will be important. So then you click on estimates. Okay, in the estimates, again, when you select backward stepwise, it will show you the variables which are important. Okay, so intercept values, I have 2 choices. So I have 3 choices basically in the data. I have 3 choices, mode choice, 3 choices, and this will be for you as well: car, others, and autonomous vehicles. So you will see 2 intercepts, no problem, they should remain as it is, and it is showing the coefficient for variable 4. Variable 4 was age, I think, age or experience, something like this. So this is the coefficient of age. So intercept means the constant for the model, and the coefficient is for the age variable. Okay, so if you want to develop a model to predict mode choice, okay, it will look like this. So utility of, let's say, car is intercept of car. Let me put it in bracket, plus coefficient and the value of variable 4. Okay, So for example, if you put the value of variable 4 for me, if you put my age here, it will give you how beneficial for me. Okay, if you put it for yourself, then it will show you how beneficial car is for you. Okay, so this will be for car. So you are putting the intercept for car and the coefficient for car. Step 2 is for shared car. Okay, in your case it can be other or autonomous vehicle. Okay, and variable 4 is the coefficient is. Okay, so if you want the utility for shared car, you take the same thing. Now the intercept should be for shared car as well, and the coefficient should be for shared car as well. The coefficient of variable 4 should be this one as well. Okay, so this is what I can tell you right now, because we haven't finished the topic of the mode choice. Okay, and as I said, if all of you do the evaluation, I can give you the extension and the report submission as well. But if there is no extension, if you submit up till this, you do this and you submit, I will accept it. Okay, and once you do it, you can tell me that, doctor, we have done it up to this much, and you want some further explanation, I can give it to you, no problem. Okay, any questions?
No, doctor, thank you.
Okay, thank you. Have a nice week. See you guys next week, inshallah. Assalamu alaikum.
Thank you.